Hello, we're going to look at example 19, and it says use mathematical induction to prove n squared is greater than 7n plus 1 for all n greater than or equal to 8. So we're going to go through our steps. Note this is an inequality one. This is in the sequence of numbers, so the method that we use for doing this is going to be a little different. So we still have to label it correctly like I did in the last video. So the first step is make sure it works for the first statement in the first sequence. So in this situation, n's not equal to 1 like we had talked about in the previous video. It's not going to always equal n equals 1. What's the first part of the sequence? It's when it only works for n greater than or equal to 8, right? So 8 is the first time. So I'll go 8 squared has to be greater than 7 times 8 plus 1. This is 64. This is 56 plus 1, and indeed 64 is definitely greater than 57. So piece of 1 is true. Good? So that's the first step. We did a piece of 1. Now the second step is piece of k. I need to assume that k squared is greater than 7k plus 1 for all k greater than or equal to 8 is true. It's very important that you do this part right here. Eliminating anything so far right now it could cost you points on your IB exams. So the first two steps are the easiest. Think of it as long as you follow these three methods, just easy points, right? Now the next step is piece of k plus 1, and I want to show that k plus 1 squared is greater than 7k plus 1 plus 1. So that part's easy because all you're doing is plugging in k plus 1. But we want to show that this guy right here, the left-hand side, is indeed greater than the right-hand side. So like we did before, there's not a sequence of numbers. We have an inequality, but the concept still holds. You want to work from the left and show it from the right, not the other way around. So we're going to start with this guy right here. So what is k plus 1 squared equal to, right? K plus 1 squared is equal to k squared plus 2k plus 1, right? Now here's where I can use my assumption, right? I can set up another inequality over here, right? Because k squared is definitely greater than 7k plus 1. I know that to be true, right? So if I substitute it and write it to the right here, what is this guy right here? I'm going to put something that's smaller in to the right, so this guy is definitely greater. So it's going to be 7k plus 1 plus 2k plus 1. So I plugged in my k squared with 7k plus 1. Now I want to make it look like this. So what would I need? I'll just look at the 7k. What would I need it? I can't factor it out quite yet, but I know if I added 7 to it, then the 7 could factor out to that. So this is still greater than 7k plus 7. But I just added 7, so I want to make sure these two are equal, right? So I'm going to subtract 7, and then I'll have 2k, and I have another 1 plus 1 is 2. Now I can factor it out. This is still greater than 7k plus 1, right? And then I'm going to have plus 2k, just write it in proper form, minus 5. So I'm almost there. I'm getting closer, right? I have that formulated. But now I need to make this guy right here plus 1. So if I add 1 to it, I get 7k plus 1. I'll add 1 to it. But if I add 1, I have to subtract it. Another 1 to make sure these two from here to here is equal, right? And it's going to be plus 2k minus 6. Now, I almost have it, but I got this kind of pesky guy right here, right? Now, I can pretty much change this any way I want as long as I know the right side stays smaller, and as long as I get smaller. If I get bigger in any way without, well, I made stuff bigger, but then I subtracted it, so I kept these all equal. I could take things away as long as I'm sure that it would make it this guy smaller, right? Like taking this negative away wouldn't make that one smaller. It actually makes it bigger, right? So I can't just take away the negative. But if I look at as a whole right here, this guy as a whole, I can see our k value has to be for this. We're not going to use this for values, that are not, we have to use k greater than or equal to 8. When I put 8 in here, you can definitely see it's going to be a positive number. So I can safely say that k minus 6 is going to be greater than 0 for k greater than or equal to 8. Good. Since that's always going to be a positive number, by taking it away, it's going to stay strictly less than, right? So my inequality holds, right? So I can then write the inequality 7k plus 1 is definitely smaller than this guy. Or better yet, all these things were equal on the left-hand side, and then I showed it over here. And then I have to finish off the proof with my statement, and I can say, therefore, if piece of 1 is true, and if piece of k is true, implies that piece of k plus 1 is true, then the statement is true for all k, I should say, n greater than or equal to 8. There you go. And that's it. And then you can put a stamp of Q, E, D. Look that up if you haven't already. Sound good? Thanks.